Welcome back to Steve Robb Reviews. Today we're going to have an interesting subject. It's going to be all about the top 10 questions that I've been asked about all my electrical testing videos that I've done. I'll put a playlist down below and you can take a look at them, and there's a wealth of information there for people that are interested in learning about electrical testing and the results that I've gotten. So I'm going to discuss the results that I've obtained over many years, and mostly from up my camp in Northern Ontario. I have an off-grid cabin, and I've got a 400 watt panel system set up. I've got 4 100 watt panels. I've got a power inverter, and I've wired the whole camp off of solar, but I also have it also wired for my generator as well, 2 separate systems. And I'll show you that in the future. But for today, I'm going to take the list here, and I'm going to tell you what these top 10 questions are. And we're going to explore them because I find a lot of these questions very fascinating. There's a lot of people that are interested in just getting, like you can see here, just a small little 300 watt power inverter to up a power inverter for their little cottage or their trailer or a hunting camp or anything like that. And a lot of people are asking me lots of questions about the setup and what is my opinion about all the testing that I've done. Okay, so the first question is an amp, a watt, and a volt the same on AC current, which is the current that comes out of your utility, like this little outlet here comes from your electrical supplier? Is it the same as DC? Well, it'll be interesting to read the comments below because you can learn just as much as I can by answering some of these questions. And I've got some really experienced people that are in the electrical field that could help out. But I'm going to say no, only because of my testing that I've done over the years. When somebody asks me, and I'm going to be specific, the only one that is not the same is watts. Because in my experience, when you're trying to do a calculation of figuring out, okay, so you've got a certain appliance that runs off of so many watts on AC, your household current. You do the formula to figure out, okay, if something has to run at 900 watts, is it the same as 900 watts DC? And I'm saying absolutely not. And for the only reason why I'm saying it is you have so much losses going on through your inverter. Your inverter is not like your utility, 100%. The wattage is not 100%. There's a lot of losses that go through, not just that, but your conductors. There's all kinds of influences in how your system is built, especially when it comes down to your inverter. Generally, the less money you spend on your inverter, the less efficient it's going to be. And you can't really do the calculations the same. So I'm saying, yeah, an amp is an amp, AC or DC, and a volt is a volt. It's just a unit of measure, and you have to measure it. Now, both of them, you have to measure differently. You have to measure AC amps with an AC meter, and you have to use, a DC meter to read DC amps or, DC volts. If you take a look at your plain multimeter here, yeah, you have to pick either AC or DC. Now, I guess the question really was, when it comes down to watts, is it AC or DC? And, I have done just the formula roughly, when I discussed about different electrical testing videos. And yeah, I'm just using the same, Ohm's law formula to get to different values. But in reality, I've never seen where it works out correct. For me, I've always noticed at least a 10 to 20% discretion between what the values would be in AC compared to DC. So I'm saying if you're going to try and figure out anything with wattage, and it has to come with an equivalent of DC wattage, well, bump it up about 15 to 20%. Because what I've tested myself, in the efficiency of the inverters. I'm just saying add about another 20%, you should be fine. Okay, how do you match 12 volt battery cables to your inverter? Well, I'll tell you, the biggest mistake that I've seen people do is they go and they buy themselves an inverter. Now this, take a look at this inverter right here. It says 300 watts on it, right? But on one side of the receptacle is 150 and the other side is 150. It's not 300 out of one. So when you buy an inverter, there's all kinds of different styles. You got 12 volt, 24 volt, 36, 48. There's a big variance in the amount of inverters out there. But for today we're just going to really talk about 12 volt. But a lot of inverters are sold, and they're all sold in wattage. And to match the cables, you have to match the wattage. And we're going to get down to this. Is it AC wattage or is it DC wattage? And I'm telling you that if you take a look at these cables here that come with this little unit, you know, for 300 watts, well, it's fine. The cables are fine on it. But in most instances, when you get up to, say, you start going over 1,000 watts, you know, or 2,000 or 3,000 watts, well, you're actually needing more amperage than what your house provides. The average householder has amperage between 100 amps and 200 amps. Well, in my situation that I've done testing over time, and I'll show a little bit of this today, yeah, you're way above, you know, 200, 300 amps many cases, depending on how big your inverter is. And you're getting a 3,000 watt inverter, yeah, you're drawing more amps than what a household would draw. So we'll get into that a little bit and explain the math that goes into figuring it all out, because a lot of people are very confused between, they look at the ratings 120 volts and then they take a look at the wattage or the amperage, and they have a hard time figuring out what you need for cables to supply that. And I'll get into that too. Okay. Inverters are rated in wattage. How many watts do I need? Well, like I say, depending on what kind of inverter you have. Now there's some that are hardwired. The one that I have up my camp is hardwired, which means I'm getting the full capacity because I'm wiring it directly. You know, I got 3 conductors at 120 volt coming out to my small little plugins, and you know, that's a 2,000 watt inverter, so I'm getting the whole 2,000 watts. Like I say, many times you'll see an inverter for sale and they'll have 4 plugs going across the front saying 2,000 watts. Well, sometimes they're only 500 watts a plug. So you have to be careful, because a lot of times you're expecting to plug in a coffee pot, you know, into a 2,000 watt inverter that is rated for 2,000 watts, and you're never going to fire nothing up, because, you know, you just imagine 2,000 watts with each plug having 500 watts. Well, you ain't going to get too far when the average coffee pot or a coffee maker is maybe 900 watts. So you got to be careful what kind of inverter you're buying. A half decent inverter will tell you how many watts out of each outlet, and that makes a huge difference. So, you know, when it comes to how many watts do you need, well, it depends what you're using it for, right? You have to know all the appliances that you're going to actually plug into, and what's the load, what's the amperage, what's the wattage. And then you have to figure out, you have to go reverse, you have to back this all up and figure out how many amps you need coming out of your battery. So it's not so easy to do, and I'm going to get into this a little bit. And yeah, there is a little bit of math, but it's going to be basic, easy math that everybody can figure out themselves. But generally, when you buy these inverters, many times, especially the ones that they say you can hook up to your automobile, well, they don't come with cables that are big enough to actually hook up to your automobile, and they come with alligator clips, and alligator clips, for the most part, nah, stay away from that kind of stuff. When you start going, you know, anything above 500 watts or 1,000 watts, alligator clips not the best. Okay, how big of a battery bank do I need? Well, in my particular situation, I first started off with just one 12 volt battery, a deep cycle battery, just a regular deep cycle battery you would buy anywhere. And I had a 400 watt power inverter and a 100 watt solar panel on my cabin. And all I used it for was just running my lights inside and charging, say, a cell phone or that kind of stuff, right? And that's all we used it for. So, I mean, for me, that was fine, and that's all I needed. And I went for like 10 years like that. No problem. I had no problem. I had lots of lights inside, you know, charge all the cell phones I want, this kind of stuff. And I never had a problem. But then I went and decided, okay, I wanted to get a fridge. So that changed everything, and I had to do all the math over again and figure out how many batteries I needed. So now I've got 4 6-volt batteries, and I can run a fridge only from the spring to the fall. And that's because when it gets colder climate, like it's colder outside, my batteries are actually outside behind my cabin. When it gets colder, guess what? The batteries don't have the same capacity. And that's something a lot of people don't think about, is the cold really does reduce the amount of capacity your batteries have. And I can only run my fridge from about May to September at the most, and that's it. So it's a lot of math and a lot of figuring. And you know, it's a lot of fun. You know, you can have a lot of fun figuring all this stuff. So, I mean, depends how much you want to figure stuff out. I mean, it's very hard to ask me a question sometimes when I really don't know all the background to all the equipment that you have or what you're going to use it for, right? Should I buy 12-volt appliances or 120-volt appliances like a fridge or a coffee maker or microwave, all that kind of stuff? Okay, so my recommendation, what I figured out myself, was I bought myself a 4 cubic foot 120-volt fridge. Now, I just bought mine at Costco, and you know, it's just a regular one you plug into your house, right? Now, I paid like $160 for that thing. If I tried to buy the same size in 12 volt, it'd probably be, depending on the make and everything else, anything between $500 and $1,000. So there's a big expense right there. Now, are they more efficient? Do they run better? I really don't have that much experience with them, but I've looked at their numbers and their specs, and I'm saying if I'm going to have a power inverter on anyways, I have the power inverter, I'm using a power inverter, I might as well go 120 volt. Might as well go with regular household appliances. I just, you know, plug in and that's it, away I go. Now, myself, I don't use any high loads at all. The highest load I use is the fridge. I have a generator that I run for my you know, if I want to plug in a coffee pot or a microwave or anything like that, I can start up my generator, and you know, for the amount of time, that's what I do, because I know that when I have my fridge on, I can't have another load that much when I only have a 2,000 watt inverter. So there's a lot to think about. And remember, the higher wattage of inverter you get, well, the more amperage it's going to draw from your batteries when everything is shut down. So I mean, like if you don't have anything on, a lot of these inverters, like the one that I have right now, it draws 2 amps. So between 24 and 25 amps in a 24-hour period, if that's not, just by being on. Now this one here we'll test today, it's probably around a half an amp. And this is only a 300 watt inverter. Okay, please explain how lower battery voltage affects batteries and inverters. Well, the one thing that I've noticed is when you're looking at getting a power inverter, when you're running off of batteries, it's not the same as your utility. When you have your utility outlet here, your plugs, you have unlimited potential. The difference between what you're drawing in, you know, in amperage to your particular appliance and the utility. The utility's got lots of, you know, potential to provide you everything that you need. But batteries are not the same. So there's 3 things to consider. The conductor size of your cables, the efficiency of your inverter, and the appliance you're plugging in, and the load. Because every time I've ever looked at it and I get my meter out and I test all these things constantly, you put anything on an inverter that is, say, over 5 amps, you'll get a voltage drop. When I'm talking about Fully charged battery is 12.6 for 12 volt batteries, and you will get a voltage drop. And remember, when your voltage drops, your amperage goes up. So the amount of amperage that you need to be supplying your inverter goes up as your voltage goes down. So when you're doing your calculations, I don't use 12 volts. If you go to a lot of online sites, you'll see where they say, they just use 12 volts as a reference. But really, I use the voltage that I'm actually experiencing. A fully charged battery is 12.6 to 12.7. And I've never driven my batteries down so low and discharged them to 12 volts. Because 12 volts, you're 50% or less discharged your battery. And I don't do that. Like there's a lot of inverters will say, oh, they'll shut off at 10.5 or they'll shut off at 11. Well, to me, that's way too low. And if you actually got your meter out and start reading the voltage that's coming out of your 120 volt circuits, it's way down as well. And the amperage is spiking up like crazy on the back of your power inverter to provide the same amount of amperage out your 120 side. So 120 coming out in amperage is a lot different than the amperage that needed at 12 volts. Yeah, it's kind of sounding confusing now, isn't it? But there's two different systems, and the hard part about explaining about inverters and batteries is they're two separate entities. You got the 120 volt side and you got the 12 volt side. Okay. What tests should I need to do, and what testing equipment do I need? Well, this is the basic testing equipment. I've got other testing equipment, like I say. I have a playlist down below. You can take a look at all the different testing equipment I have. But this is what I'm saying is the minimum that you need. And, it's not cheap. I think this would be like maybe $500. You can get away with less if you want. I'm not too sure. I'm just saying this is what I got. Is about $500 worth of testing equipment. Okay. What type of circuit protection do I need? Fuses, breakers, and how big of a fuse or a breaker? Wow, that is a really loaded question, because a lot of people don't realize the amount of amperage you actually need. So just roughly, this is just rough figures. If you have your household, I've got some wire here, I'll show you. This is your regular 14 gauge household wire. This is good for 15 amps. So if you've got a breaker, a 15 amp breaker, how much amperage do you need from your battery for a 15 amp breaker? Well, you're going to need anything around, it could be between 145 to 165, depending on the voltage. But generally, around 150 amps you're going to need through the cable to your inverter to get 15 amps AC. Now that's a huge differential, isn't it? You got a 15 amp breaker in your house and you need how many amps just for 15? Well, you need a minimum of 150 for a 15 amp circuit on 12 volt. So I'll show you the different fuses that I like. And breakers, I do have breakers and I show breakers. And I have one video there where the breaker failed on me. I'm not a big fan of the breakers at all, the resettable ones. I do have them and I'm going to use them, but I am going to convert over to the other ones because, yeah, I'm noticing that over time I'm getting a lot of loss through the breaker and I don't like the breakers. So just think about it. If you got a little cabin and you want to have, say, 15 amps going to your cabin, well, take a look at that cable. That's only a number 4. And that's good for about 300 amps if you have a short enough piece of it. So a lot of people say, well, how big of a cable do I need? Do I need to go to a great big huge half-inch, cable, or can I use like a number 10, or can I use a 12, a 6, or whatever? Well, there's a lot of things you have to figure out. How long is the cable run from the connection at a battery to the connection on the back of the inverter? Now you can look at a whole bunch of different sites and it'll give you the calculator, you know, and figure out how thick of a cable you need. And some of them that are better will provide how much of a percentage in voltage drop is acceptable. Some at 1%, some at 5%. So there's so many variables that you have to learn about this. But I use number 4 cable, and for 15 amp it's fine, and I think that's about the lowest I would go for a 15 amp circuit. And you know, and you still get some voltage drop. So okay, do I need a modified sine wave inverter or a pure sine wave inverter? Well, I've never had a pure sine wave inverter, and I can run I have a digital microwave. I tried it out. Yeah, I can run the microwave off it, but it draws way too many amps, you know, so I just don't. It's not really worth it. You can run a coffee pot, like a regular coffee pot, you know, like a regular coffee. What it doesn't like is a lot of stuff that is digitally controlled. Now I have a TV. I've got an LED TV. I have no problem running it off that. But I have noticed that, you know, some of the lighting that I've gotten over the years, I used to have the, you know, the round curly bulbs, the first ones that came out that were energy efficient. Well, they would flicker. And, you know, I changed one inverter to another, and yeah, it would flicker. On the small little inverter I had, like the 400 watt I said in the beginning there, no flicker, no nothing. I got the bigger 2000 watt inverter and they would flicker. So I put another bulb in there, surprisingly, an LED high efficiency bulb. Never flickered, never had a problem with that. But generally, do you have to spend the extra money on the pure sine wave inverter? Well, you're going to probably spend, to get a half decent one, at least 3 times the prices of most of the inverters that you see in the market today, or more. And yeah, like medical equipment, you can go through a lot of websites and you can search online to see what kind of appliances you actually need for a pure sine wave inverter. And for my uses, well, I've never, you know, like I run a fridge off of mine, and you know, like that's not a digitally controlled fridge, it's just a regular bar fridge, right? Okay. What are good battery brands to buy and inverters? Well, that's something you're going to have to, you know, like watch YouTube videos and find out what's a half decent inverter and how much do they draw when they're on and not being used. I mean, there's things that I've done, you know, to show people on the inverters that I've tested, but generally, like this inverter here, I wouldn't recommend this kind of inverter because when you turn the inverter on, I don't know if you can hear it or not. So you turn it on and the fans go on automatically. Well, I really don't care for that too much. Now, the inverters that I've used, they only go on when they detect a certain amount of heat, or if they draw too much amperage, then the fans will kick in, you know, if required. And that's the ones that I prefer. Now, as for brands, well, really, you can spend too much on a power inverter. I mean, there's some really good brands out there. Do you want to spend $2,500 on a 2,500 watt inverter when you can buy a really good, you know, 2,500 watt or 3,000 watt inverter for about $500-600? So it depends on how many amps you need and what is the purpose of the inverter and how efficient of an inverter do you need and your whole setup. So there's a lot of things to consider, but generally the bottom end of the inverters I would kind of stay away from. You know, like if you're going to use it to depend on, no, I stay away from the bottom line. Now for batteries, what do I use? I like myself the Costco batteries, the Kirkland batteries, and so I went to 4 6-volt batteries. So it's still a 12-volt system, and I believe each battery is well, it's close to 200 amp hour each battery, and that's a whole nother discussion about amp hours and everything else. So that's the questions there, and the only thing I'm going to do today is I'm just going to show you a couple of things about the testing. And this video is getting long as it is, but these are things that I think a lot of people are fascinated about, and they're not too sure, what equipment they should get, what inverters they should get, how to match the whole system up, and we're going to talk a little bit about that. So let's go to the testing right now. Well, what do I use for test equipment? This is right here, one that you can pretty much use, a lot of people could use, and it's an amp clamp, and it tests voltage, amperage, AC, and DC. The only downfall to this, it only goes up to 80 amps. So to go higher, well, you have to get a rig set up like this, where it actually uses the calibration in your digital multimeter on millivolts to give you a reading, and it'll display it in amperage. So if we just turn this on right here, and it's so easy to I'll just show you here. We're going to turn this to right there, and that is up to 4 amps, and we just zero it out. And now we're going to just measure the amount of amperage that is drawing down when it's on, and around 2.7. So I mean, yeah, around, so it's about between 0.2 and 0.3, that's for sure. And there's a lot of tests that you can do, and the main one that I would say you should really test is the voltage, because when you think about it, voltage is what you're going to actually be having coming out your receptacles here. So let's put the meter on and let's test some voltage readings. Okay, so to test voltage, you just plug it in your 2 outlets here. And what do we got here? 120. Now that's pretty good. Now coming out of my utility here, I don't know if you can see that or not, but under my utility here, same thing, 120. Now, another test that a lot of people should be doing that they don't is Hertz. So we're going to go to Hertz and plug it in here again. And what do we get there? Can you see that right there? So that's showing 58.7 Hertz. So in North America, we're running off to 60 Hertz. If I plug it into my utility here, it'll be exactly 60. Well, I'll just do that. Plug it into my outlet here. There we go. 60. Bang on. This here, 58. I have seen these down to about 52, 53, and that's not good. So you really have to check the amount of voltage coming out, and it's nice to actually test it while it's under load. So, and I do that with my other electrical testing videos. But so now we're going to get to this one here. Now this one here is good up to 400 amps, and I regularly test like well over 150 amps constantly out of my inverter just to do various testing. And it's the same way, it's an amp clamp where you can plug it around here. So I'll just turn it on here. There we go. 2.8. Put it around this conductor. 2.3. I mean, it's not that accurate, but this is only meant for anything above really an amp. So even still, it reads pretty good, But I would say one of these will probably suffice for most people, for doing, regular voltage reading and amperage reading up to 80 amps. I mean, it depends on how big of a system you have. But when you think about it, you're going to need something like this when you've got any system that's drawing at least 15 amps, because out the back it's drawing 150. So you can have a lot of fun with the testing procedures and figuring out through Ohm's law the exact losses between the battery cables in the back and what's coming out the front in AC voltage. Well, I hope you enjoyed the top 10 questions that I've gotten so far on inverters and electrical testing. This is just a basic test right here. But generally, you know, when you're thinking about hooking up battery cables from your battery to your back of your inverter, you have to just follow the Ohm's law. That, you know, the relationship between volts, amps, and watts. And remember, whenever you're using wattage, kind of put on at least 10-15% added wattage, you know, when you're thinking about the losses going through an inverter. But if you, there's so many websites out there that show the calculators. You can Google, you know, all kinds of different calculators for figuring out, you know, different equations for how big of a cable do you need, how many amps do you need. So I'm just going to show you the fuses here. Okay, these type of automotive fuses stuff, you know, like the stuff that you've seen here before, you know, where you got these type of fuses. Nah, none of that stuff. I'll tell you something. I've seen that before. And, you know, I get the questions, how come my fuses keep blowing, right? Because, you know, they're putting in a 30 amp fuse and it keeps on blowing. And I'm saying, well, you know, these little Mickey Mouse cables here, yeah, you ain't going to get very many amps going through there. Okay, so this is the fuses that I recommend. So this is the little kit that I got, and I'll just show you the fuses. And these are the only ones that I really like. And you can pick different amperage. Now this one here that I got here, and they just kind of slide in. See how this fuse is made? Just fits right in here like this, and you put your battery cables one here and one here. Now people are going to say, another question I've gotten before is, should I put the fuse on the negative side or the positive side? Well, for me, it doesn't really matter, but generally you want to put it on the positive side. I have put them on the negative side only for convenience, but for people that are actually having any kind of an attachment to here downstream or on the negative side or the positive side, now you're better off to just stick with using the positive. And these here just kind of slide in like this, tighten them down, and you know, it's very simple. And this one here is a 300, I believe. So I got some that are 150, I got 300, all kinds of different types. And you can screw these down, you know, to wherever you want, and it's rock solid. So I mean, I think that's the way to go. And then it's got a nice cover over top, and you can have your cables, you know, come through. And when you want to disconnect the circuit, well, all you do is just loosen up the one side, slide it over, you know, and that's it. It's disconnected. Now I like that a lot better than going with these breaker style. And I find that this style here is much better, more reliable, less losses in the system, and you have to use good crimped on. I use crimped on. You can solder them on. I use good crimped on brass connectors, and you have to actually match the connector to the cable end. I've seen some people use really small Mickey Mouse connectors on the ends. You just burn them right up. I mean, when you're talking about, like I say, you have to figure out your Ohm's law formula. But when you got 15 amps that you're drawing out of your inverter, and you need a minimum of between 145 to 165 amps, well, you're going with a cable like this, right? So you see how big this cable is compared to, you know, just a 120 volt line. So there's a relationship between voltage and amperage and wattage. So the only variable is the wattage. Like I say, just add about 10 to 15% on top. But when you're figuring out your cables on the back of your inverter, it's best to go a little bit bigger than a little bit smaller. Yeah, there's more cost involved, but you have to actually do the math and figure out what is the total distance from the back of your inverter to your battery connections. That makes a huge difference. I can go up to 300 amps with the number 4 cable with a 1 meter run. I go to a 2 meter run, man, I'm into like 1/2 inch battery cables, you know, big time, because the losses. And this is what a lot of people, you know, need to do is measure. And like I say, I've done it over the years with measuring with my clamps. So I've done the math the hard way by measuring it, not by actually using all these formulas that you see online. Because a lot of times, well, they don't ask enough questions. And there's a lot of variables that go into setting up a battery bank, a power inverter, you know, and then what's downstream? What are you plugging it into, right? What's the duty cycle? There's a lot of things to learn. I'm still learning myself, and I learn from a lot of people on YouTube that actually talk about these things, and I enjoy it quite a lot. So thanks for joining me here today, and I hope I've explained the best I can. If you have any questions, put them down below, and in the future, well, I'll read your question out and see if we can get it answered as easy as possible. You guys take care. Come back again. If you haven't seen this channel before, you're welcome to subscribe. We're going to have some more fun. Cheers.